Hi everyone, it's me again. We are looking at how to sketch the graph of the square of f of x when we are given f of x today. Now, some of the properties of the graph of f of x and how does it affect the squaring of that function. First, we look at the x-intercepts. The x-intercepts are points where the y-coordinate is 0, so x-intercepts will remain unchanged because as you square the y value, the y-coordinate, which is 0, 0 square is going to be 0. So this is something that is going to be very important because it helps us to know some of the points or some of the important points in the square of the fx graph. If you look at the y-intercept, say for example is 0a, it will still be a y-intercept, but the coordinates will change. It will become 0, a squared. So the y-coordinate has to be squared. In terms of the turning point, it's going to be changed as well. It will still be a turning point, but the coordinates will be h, k squared if the original turning point is hk. So what you can see is that while the x-coordinate remains the same, the y-coordinate is being squared. Now, one of the points that is going to be interesting are points of the form p, 1. These are points where the y-coordinates is 0. Now, these coordinates will remain unchanged because what happened is that when you square 1 square is still going to be 1. So again, this something like the x-intercepts are very interesting points on the square of f of x. One part about the square of f of x graph is actually the position of the graph. And we can categorize them into two different regions. The first region, which you see, is that when fx is between -1 and 1. Now, in this region, right, what happened is that when you square f of x, when you square a number that is between -1 to 1, for example, like half, when you square half, it becomes 1/4, which means to say that, right, it will result, the effects of this squaring will result in a smaller fraction. And as a result, the graph will actually become flatter compared to the original graph. Whereas if you look outside of this region, when f of x is less than -1, or when f of x is more than 1, the effect of squaring will make the values larger. For example, like 2, if you square 2, it's going to be 4. So as a result, the graph will actually become steeper compared to the original graph itself. What we can do is we can actually use an example to look at how we actually can sketch it. One approach that you can do when sketching the square of f of x is first you identify the x-intercepts because these are the points that are going to remain unchanged. Also, after which you actually can start off to look at where the turning points are going to be. And from there, you can roughly see the outline of the graph. And lastly, it is to analyze the different regions of the graph. All right, predominantly will be the region where f of x is between -1 and 1, and as well as when f of x is lesser than -1 or f of x is more than 1. So we're going to start off with a very simple example. What we see is that if f of x is a linear line, which is when x equals to when f of x is x minus 1, what you can see is that the square of f of x, it's going to be x minus 1 square. And what we understand about this graph, that this is a parabola, obviously, but how can it be achieved from looking at the straight line x minus 1? First of all, what we know is that the graph itself will have the same x-intercept as before, meaning to say, if you look at the linear line x minus 1, the x-intercept is 1, 0. The square of x or 1 will also have an x-intercept that is 1, 0. So you know that this is the x-intercept for the square of f of x. And if you also look at the point 2, 1, which is on the straight line itself, this point will not change as well because the y-coordinate is 1. So when you square 1, it doesn't change the y value. But what we can do is we can actually look at two separate regions. And what do I mean by that? If I were to do a dotted line down here, and this dotted line separates the region to be between f of x between -1 and 1, and the other regions, which is f of x greater than 1 or f of x lesser than -1, what we see over here is that within this region, when you square the y value, you will result in a smaller y value, and as such, the graph will be flatter. So what we can expect is that we can expect the graph to be something like this. And over here, it will be something like this. Note that this y-intercept, which is 0 minus 1, when actually you square it, it becomes 0, 1. So what you see is that the new y-intercept is going to be at 0, 1. And then beyond this region, what you see is that the graph will increase, because when you square, say for example 2, you get 4, which means that the y value is going to be bigger after squaring. And you can see the graph will increase faster than the straight line, and this becomes your parabola, which is y equals to f of x holding square. In this case is x minus 1 holding square. Well, I hope that this is useful to you. And if there's any questions, feel free to put in the comment box.